So I just tied on this really cool bandana that I have of the constellations on Darth Vader here because I'm going to talk about stars in this episode. So yay! Stars and the different sizes in our Milky Way galaxy. So, from dwarfs to giants to main sequence stars, there's a vast array of different stars and sizes in our Milky Way galaxy alone. There's somewhere around 100 to 400 billion stars just in the Milky Way. And most of these stars actually exist in what's known as binary pairs. And binary pairs are literally two stars orbiting one another, as opposed to like our sun, for instance, which totally exists by itself. And that's actually pretty rare in the universe to find a star. And it's like totally out there, just like riding solo. But most of the time, stars actually exist in binary pairs. And there's a few theories to discuss as to why that is. One of them is because stars tend to exist in clusters, and they tend to form in clusters. Now, since stars tend to form in clusters, there tends to be more dense regions than others in the clusters, and this is where the stars could have paired up and become a binary system. And there's another possibility, which is the breaking up of disks around newly formed stars. Now, where exactly do these disks even come from? Well, it has to do with the beginning of star formation. Now, where exactly does a star even come from? So, you have generally an interstellar cloud, or sometimes they're also called interstellar nurseries, like for instance in the Orion Nebula. There's lots of dust and gas, all kind of just everywhere. And there's certain regions where it tends to be more dense than others, and that will collapse into a star. And when that collapses into a star, the star starts to rotate. It starts to spin like a lot. And from it spinning, all of this nearby dust and gas starts to accumulate around it. And when you start to have this, then you have a form of a disk really forming around the star itself. Now I know this is a lot of scribbles, so let's like erase the rest of the interstellar cloud. So now you have the star that's like in the center, and it's starting to collect all this nearby dust and gas, and as it gains more matter into the disk that's surrounding the star, there a lot of times will be certain regions that it'll be more dense than others. Maybe there's more dust that's collecting in certain areas. It really just has to do to the accumulation of dust around the star. And when this happens, the disk starts to become unstable and pieces of it can break off. And when those pieces start to break off, a new star can form from those pieces. And if this star forms shortly after this star had already formed, then these two start to become gravitationally bound, and they become then a star system, a binary star system. So that's really interesting. But other than binary stars, what's interesting too is like the Pleiades star cluster. The Pleiades, also known as the Seven Sisters, and that's specifically because there are 7 pretty dominant stars that we actually can see when we look up in the sky. We totally unaided eye, we do not need a telescope to see them. They're found in the constellation Taurus. But it's actually an open star cluster that contains somewhere around 1,000 stars, and they're around like midlife, so about 50 million years, which is quite interesting because what we can see is like a dominant 7 stars in the sky, part of the Pleiades star cluster. And the thing is that you have this accumulation of all these stars that have really become gravitationally bound. And other than that, you also have something known as globular clusters. And globular clusters have somewhere around thousands of stars that tend to all accrete nearby each other. So that's pretty much star clusters. But now let's get into the different types of stars and their sizes. The first one is really interesting to me. It's the teeny tiniest star that's out there, and it's known as a neutron star. Neutron stars are around 20 to 40 kilometers in diameter. So that's like their scale that would be going across around the neutron star itself. And I actually calculated this. That is about 186 football fields to about, I think it was like 240 football fields, but 186 football fields starting. So that would be if it was a 20-kilometer diameter of a neutron star. So they're relatively not that big, to be honest, if you think about it, as opposed to other stars like supergiants, but we'll get into that in a little bit. Neutron stars, to me, are extremely interesting because they are very, very dense stars, and they tend to emit sometimes really big bursts of radiation in the form of X-ray radiation, which is actually pretty cool because I did a video on ULXs, if you guys want to check that out. But now this brings us to the next type of star, and that is a white dwarf star. And white dwarf stars are the remains of the core of a dead star. So there was a star that expanded into a planetary nebula, because stars all die totally differently. So if you have a star that is around 100 solar masses, so that's like 100 of our suns combined in one star, when it dies, it starts to first expand, and it expands and puffs out into this planetary nebula, because it starts to puff out all of its remains of the star. So it turns into a gas. And when a planetary nebula forms, what's left in the center is that little core, and that's known as a white dwarf, around the size of Earth, with a surface temperature of about 100,000 degrees Celsius. So it's pretty hot. As it starts to really get older, it starts to cool in temperature, it actually starts to darken in color and slowly starts to become what's known as a black dwarf. So it's really, really interesting. Then now let's jump to now the next extreme, which would be like supergiants. And supergiant stars are so cool. I love it. So one awesome example would be like Betelgeuse. Betelgeuse is a red supergiant star. It's probably going to end up dying via planetary nebula. Supergiant star can be around 1,500 times larger than our sun. Our sun coming in at about 695,000 kilometers in diameter. That puts some of the supergiants at 1 billion kilometers in diameter. Remember those football fields I was talking about? Yeah, this would be around 9.2 billion football fields. Man, I love astrophysics, it's so cool. Stars like these, like supergiants, are actually stars that are nearing the end of their lives, where they once were part of the main sequence, and now they've expanded into a large size because they're nearing the end of their death. Blue supergiants. Let's take Rigel, for instance, which is found in the Orion constellation, about 20 times more massive than our sun, and is around 20,000 to 50,000 degrees Celsius on its surface temperature. And it gives out more light than 60,000 suns combined. That's really, really insane. And these stars are quite rare and have very short lives. They live for only about 10 million years in comparison to stars in the main sequence. There's about 90% of stars in the universe, including our sun, that are on the main sequence, ranging from about 1/10 the mass of the sun to 200 times the mass of the sun are the stars that are found in the main sequence. The nuclear fusion happening in these main sequence stars are fusing hydrogen into helium. And these stars normally live around 10 billion years in the main sequence until they begin to evolve into a red giant star and then die. Now, for stars less than 0.08 the mass of the sun, they are unable to reach the stage of nuclear fusion, and their core instead becomes really cold, and they eventually become brown dwarfs. Now, brown dwarf stars are never ignited, meaning nuclear fusion never happens. But if there is just enough mass in the star where the collapsing gas and dust burns hotter, eventually reaches temperatures high enough to fuse hydrogen into helium, aka nuclear fusion, then that's when it would then become a main sequence star. So now in my next video, I'm going to talk about some of the weirdest stars that are out there in our galaxy. So definitely stay tuned, and if you guys like talking about astrophysics, please like and subscribe this video, and I'll talk to you guys next time. Bye! The Pleiades, also known as M45, is because it is found in the Messier catalog. There was this French astronomer named Charles Messier who ended up finding 110 astronomical objects in the sky and cataloged them in the catalog known as Catalog of Nebula and Star Clusters. and it was created in order to prevent comet hunters like himself from wasting their time studying these deep sky objects that were not comets.